Okay, today we are talking about circular motion. So, circular motion, going round and round in circles. Feels quite familiar in my life, to be fair. Now, let's imagine I go round in a circle. And more specifically, let's imagine I walk around at a constant speed. I would do a demo, but I think we can imagine it. And it's cold outside today. Now, does my velocity change? No. Wrong, I'm afraid. Yes, it does. Why? It's because when I'm moving round in a circle, I am constantly changing the direction that I'm facing. So even though the magnitude of my velocity remains the same, because I'm moving at the same speed, because velocity is a vector quantity and my direction keeps changing, my velocity is technically changing. So my next question, am I accelerating? No, because you're traveling at the same speed? Again, not quite. Remember, acceleration is not the rate of change of speed. It is very specifically the rate of change of velocity. And since my velocity does keep changing, then I must be accelerating. Remember, accelerations can cause changes in directions too, not just changes in speed. So, everything that moves around in a circle is accelerating, even if it's moving around at a constant speed. So here are some examples of stuff that moves around in a circle. Cars round a roundabout, the earth around the sun, a ball swinging around on a string. Now we're going to concern ourselves for a second with what is causing these objects to accelerate. From our work on Newton's second law, we know that there must be a resultant force acting on a body to cause it to accelerate. And when something is in circular motion, that resultant force acts always towards the centre of the circle. Wait, but surely that would mean that those objects would then just accelerate in towards the centre. Like, for example, the Earth just collapsing in towards the sun. Actually, no. That force just keeps the object moving in a circle. If there were no force acting towards the centre of the circle, like if there were no force of gravity pulling the Earth towards the sun, then the Earth would just fly off at a tangent. We need that force towards the centre of our circle to constantly pull these objects back into a circle. So, gravity pulls the Earth into a circular orbit around the sun. In the situations that I mentioned above, for the car, you have friction acting towards the centre of the circle, and for the ball, you have tension in the string pulling it towards the centre of the circle. Okay, if you found that useful, please do like and subscribe. Download the notes for the key points about circular motion and some key examples too. Thanks for watching.